Hi all, this is Dr. Shanti, Professor, ECE Department, R.M.K. College of Engineering and Technology. In this video presentation, we are going to see block diagram representation of DT systems using cascade and parallel methods. Right, now let us see what are the basic elements of realization. The first element is a delay element. So if x of n is input, if you are giving it to a delay element is represented by z power minus 1. The output what you get is x of n minus 1, which means that there is a delay by 1. The next element is an adder, right? There are two inputs x1 of n and x2 of n. The output what you get is x1 of n plus x2 of n. The third element is a multiplier. You have x of n. When multiplied by a, you get a into x of n. These are the three elements of realization. Right, for knowing the block diagram representation of cascade and parallel, you have to have a knowledge of direct form 2, which is one another method of representing block diagram representation. Right, the transfer function of any discrete time LTI system is given by this way, y of z by x of z. Now in direct form 2, what you do is you insert a dummy variable. Y of z by x of z is equal to y of z by w of z into w of z by x of z. You insert a dummy variable, multiply and divide by the dummy variable, and what you do is you equate w of z by y of z by w of z to the numerator, right? And then you do a cross multiply, get an equation for y of z. Next is w of z by x of z will be equated to 1 by denominator, cross multiply, get an equation for w of z. So this is the second equation. Now what we will do is we will implement equation 1 and 2 using direct form 2, right? And as I have told you in my previous video, in the case of direct form 2, you will have only one set of delay elements, right? And you implement y of z and w of z like this, right? Y of z is going to be b naught into w of z. So b naught into w of z, you have a delay element. So the output here is going to be z power minus 1 into w of z into b1. That will come here. The same way, when you proceed on, what will be the value here? It is w of z into, if there are m delay elements, it is going to be z power minus m into bm, right? So that is the implementation of first equation. And similarly, the implementation of second equation is going to be on the input side. See here, x of z directly, right? And here the value is 1. And what about this term? It is w of z into z power minus 1 into minus a1. That will come here. And finally, what will be the value here? It is z power minus n into minus a power n. You will get if the expression for w of z, right? You have a sequence of adders. Now what you have to remember very clearly in direct form 2 is you have only one set of delay elements, right? The numerator coefficients is going to be on the right hand side, and denominator coefficients are going to be on the left hand side, right? So that you have to remember. Now let us go on to the topic what we are supposed to see. Cascade form realization. How do you form the how do you represent a discrete time LTI system using cascade form realization? What we do here is the transfer function is going to be split up into a number of that is a number of second order or first order functions. Say h of z, you all know what is h of z. H of z is going to be y of z by x of z. Right now that transfer function is going to be split up into h1 of z, h2 of z, h3 of z, so on till hk of z. What is the final overall transfer function? It is the product of individual transfer functions. Correct? Right, now how is that we are going to see here? See the same thing represented in the pictorial representation. You have x of z as given as input. It passes through h1 of z, h2 of z, h3 of z, so on. And finally you get your output y of z, right? So it's the product of individual transfer functions, right? The overall transfer function is the product of individual transfer functions. Right, now the next method is going to be, now one thing to be remembered here is each of the individual transfer functions are going to be implemented by using direct form 2. That is why I taught you, I gave you a review of direct form 2. Okay, right. Next method to be parallel form realization. What I do in the case of a parallel form realization is I split up the overall transfer function into what I do was h1 of z h2 of, that is I take a parallel connection. There it was in the previous case in cascade connection, it was series of transfer functions, right? You had a cascade of transfer functions. Here what I'm going to do is the overall transfer function is going to be split up by using partial fraction method, and you get h1 of z, h2 of z, h3 of z. See here, the overall transfer function is nothing but the sum of individual transfer functions. In the case of cascade method, it was product of individual transfer functions, whereas in the case of parallel form realization, it is the sum of individual transfer functions. Now, how do I represent? The pictorial representation is going to be, you have x of z, right? See here, h1 of z, the overall transfer function h of z is decomposed into a number of transfer functions which are connected like this, right? And all the outputs are given to a summer, and you get your output phi of z. And once again here also, each of the individual transfer functions are going to be implemented by using direct form 2, right? Now that you have to be very clear, right? Coming on to, let us take a problem, right? Realize the structure using cascade and parallel realization. Let us take h of z. H of z is equal to z plus 1 by z square plus 6z plus 8. Now if I have a transfer function of this sort, first what I have to do is I have to look into the order. Here it is second order. So what I have to do, multiply and divide by z power minus 2. Why? Because why we go in for multiplying for z power minus 2? Only delay elements are represented as z power minus 1, z power minus 2. So since we are implementing using delay elements, we are multiplying by z power minus 2. Okay, right. Now when I multiply the numerator and denominator by z power minus 2, what is the answer I'll get? In the numerator I'll get z power minus 1 into 1 plus z power minus 1, and here what will I have? Z power minus 2 I'll have that I'll 1 will get cancelled. So so what will I have? 1 plus 6 z inverse plus 8 z power minus 2, right? Here I'll take 1 z as common, right? When I take 1 z as common, it will be 1 plus z inverse. I'll have 1 z, and the bottom z cancels, and you'll have only 1 by z, that is coming to the numerator as z inverse. I repeat, what I have is here in the denominator I'll have z power minus 2. In the numerator, when I take z common, I'll have 1 plus z inverse. So the numerator I'll have z, and in the denominator I'll have z power minus 2. So 1 z and 1 z power minus 1 here will get cancelled, and what remaining will be z power minus 1. Okay, right. Now you get the equation of this sort. Now what I'm going to do is I'm going to split this equation into h1 of z into h2 of z. So what I do is I factorize the denominator. So when I factorize the denominator, I'll get 1 plus 2 z inverse plus into 1 plus 4 z inverse. Now I can split this equation into h1 of z into h2 of z. Is that clear to everyone? Right. Now how about let us look into what I have taken for h1 of z. h1 of z is z power minus 1 by 1 plus 2 z inverse. What is h2 of z? Is 1 plus z inverse by 1 plus 4 z inverse. Now as I told you, we are going to go in for direct form to realization. And as I told you, for direct form to realization, what did I tell you? Numerator coefficients to the right hand side and denominator coefficients to the left hand side, right? So numerator coefficient is 1, right? 1 into what will I have? Z inverse into W of Z. So what I'll have? So this is W of Z, put 1 Z power minus 1. So what will I have? Z power minus 1 into W of Z. What will be the denominator? It is 1, and its when it comes to this side, it has to, the denominator coefficients, there is a change of sign except for that one. So 1 here, so plus 2 will become minus 2. You will get here. Now I have shown you here the shortcut method. Actually, how will you proceed about here? You have to take y of z by w of z into w of z by x of z, equate w of z, y of z by w of z to the numerator. Right, so what will I get? Y of z is equal to z inverse into w of z. So that is what is implemented. And in the same way, you have to find out for equate w of z by x of z is equal to 1 by denominator. So you will get two sets of equation. When we implement it, you will get this way. In the same way, let us look into h2 of z. See here, numerator coefficients to the right hand side. See here, 1 is coming right the same way. Second term will be z inverse, right? So what is the coefficient? So 1, so z inverse. These two are going to be going to an adder. Denominator coefficients to the left hand side. So this 1 as such, and the second term plus 4, so it is going to be minus 4. You will get this. So this is the shortcut method of direct form to realization. I repeat, the numerator coefficients will come to the right hand side and denominator coefficients will come to the left hand side with the sign reverse. Except for that one, the remaining terms will have a sign reverse. So this is the output. Since it's a cascade realization, we are connecting h1 of z. This is h1 of z and this is h2 of z. We are connecting one after the another. Now coming on to parallel form realization. Now in case of parallel form realization, what I do is, see here, I have h of z. H of z is going to be z plus 1 by z square plus xz plus 8. Right. Now I factorize the denominator. I take the partial fraction a by z plus 2 plus b by z plus 4. Find out the values of a and b. So the value of a is minus 1 and the value of b is equal to 3 by 2. Right. So this is h1 of z and this is h2 of z. Right. So I am writing h1 of z is minus 1 by z plus 2. You all know, if I want to do a block diagram representation, I have to convert this in terms of delay elements. So here the highest order is 1. So what I do, multiply and divide by z power minus 1. Here also the highest order is 1. So multiply and divide by z power minus 1. So I get the expression for h1 of z as minus z power minus 1 by 1 plus 2 z inverse. h2 of z is going to be 3 by 2 into z inverse by 1 plus 4 into z inverse. Correct? Now what I do is, I go on for implementation of h1 of z and h2 of z using direct form too. See here, look into the equations. h1 of z is minus 1 by z plus 2, right? Here, when I do in terms of delay elements, it is minus z inverse by 1 plus 2 z inverse. Now what I told you, in direct form too, only one delay element is required, right? Numerator coefficient on the right hand side and denominator coefficients on the left hand side. So here the numerator coefficient is minus 1, it's coming here. And denominator coefficient, this 1 will come here and plus 2 will come as minus 2 here. And coming on to this one, 3 by 2 into z inverse. So z inverse into 3 by 2. Denominator will be 1 plus 4 z inverse. So 1 will come here and plus 4 will be minus 4. So you have to implement it by using direct form 2, and x of z will be given common to both h1 of z and h2 of z. The outputs of h1 of z and h2 of z should be given to an adder and taken. You have to take the output. Thank you all students.